Alright, welcome back for another episode in Polynomials. Today we're going to talk about zeros, what they are, what they mean, how to find them, that sort of thing. We're going to, of course, start slow, but very first we need to start with a definition. Zeros are x values that make the y value of the function 0. It should say of the function 0. Or we could just think of them as x-intercepts. So these are going to be the x values where our function crosses the x-axis. But first, before we start getting into finding zeros, what we've first got to talk about is called the zero product property. Zero product property. And what on earth does that mean? Well, you already know the zero product property if you're in high school, or even probably earlier than that. You knew of the zero product property, but you might not have known its name. The zero product property happens when we multiply two numbers. Let's call them A and B. And we get 0. The question is, what can you tell me about A or B? And the answer is that one of those has to be 0. The only way for you to get 0 when multiplying numbers is in order for, or not in order, but one of them has to be 0 for that to happen. So this means that A is equal to 0, or B is equal to 0. And now, because we're using a math OR, which is inclusive, A is equal to 0 or B is equal to 0, or the very third option that nobody really considers, or both A and B equals 0. The third unspoken thing is that both of them are in fact 0, because 0 times some non-zero number would give me 0. Some non-zero number times 0 would give me 0. But 0 times 0, of course, will still give me 0. And it's this aspect, this idea right in here, well, this whole thing really, is what we use when we've factored a polynomial. If you come across a factored polynomial, for instance, x plus 3 times x minus 7, that's a factored polynomial, and you want to find its zeros, you want to find when it's equal to 0, what you do is you set each of those pieces equal to 0, because this represents A, and this represents B. So then I take all of, I didn't want blue, wanted red. I take all of A, which is x plus 3, and set it equal to 0. And then I take all of B, which is x minus 7, and set it equal to 0. And then I solve for x. In the case of the red, I'm subtracting 3 from each side, and x is equal to negative 3. Or in the case of the blue, I add 7 to both sides to move that negative 7 over, and that tells me x is equal to 7. And there you have it. Those two numbers are the zeros for this factored polynomial. And that's exactly what we're going to be doing today, is we're going to first do an example 2 of going this way, having a factored polynomial and finding the zeros. But then we're going to go the other direction, where we have maybe a graph of a polynomial, and we want to create the factored form of it. So here we go. Let's do one big example of a factored polynomial finding its zeros, and then we'll do the other example of when we start with a graph and we want to make this polynomial from its zeros. So if I have something like 2x minus 1 times x plus 3 times x minus 7 times x plus 1. That should be good. 4 things. We want to set this whole polynomial equal to 0 to find its zeros. So, of course, I got to write it all over again. I want to find the zeros of this factored polynomial. So I set it equal to 0. And then, because I have a bunch of numbers, for instance, this is one number, and this is another number, and this is a different number, and this is a different number, all multiplying to be equal to 0, I have the zero product property, which means each of those pieces should also be equal to 0. So I set each piece equal to 0, and then I'm going to solve them each to get an answer. I'm going to have to be careful that this last piece doesn't go in the way of my picture. So for this particular first one, I've now got a number in front of my x, so I'm going to have to do something about that. But I just move that constant by, in this case, I do the opposite of it, what it is. In this case, it's -1, so I'm adding 1 to each side. So I get 2x equals 1, and then I'm going to divide by 2 on both sides to cancel the 2's on the left, leaving me with just the x being equal to 1/2. And now that's one of the zeros. Here, I need to do the opposite of +3 to get x alone, and so I subtract 3 from both sides. These, of course, cancel, leaving me with just the x, and 0 minus 3 is a -3. And so x is equal to -3 is my second zero. And then for the next one, I do the opposite of -7, so I'm adding 7 to both sides. -7 and +7 cancel, which is what I want, leaving me with just that x, and 0 plus 7 gives me 7. And then the very last one, I want to get rid of that +1 to get x alone, so I subtract 1 from each side. +1 minus 1 cancel, leaving me with the x, and 0 minus 1 is -1, and so that's my last zero. Now, a very quick observation, hopefully you see, that from the factor piece to the 0, actually that's not the one I want to circle. The piece that's factored, this piece, and its 0 are just the opposites of the number. So here it's +1, my 0 is -1. That's provided there isn't a number in front of that x. When there isn't that number in the x, it's the opposite of the number. So -1 becomes this +1, and then I divide by that number in front to give me that +1/2. But every time there's not a number in front of the x, it's literally just the opposite of the number that follows. So x plus 3, the 0 is then -3. X minus 7, the 0 is a +7. So that's one quick way to speed this sort of thing up, especially if you're taking a multiple choice test that's being timed like the SAT or ACT, and they ask you to find the zeros. You can move pretty quickly through this type of problem by just taking the opposite of that number that's in the parentheses to find the zeros. Because you want to make, in this case, x plus 3 equal to 0. Well, we need the opposite of +3, which is that -3, to make that whole thing 0. Well, that piece 0. I hope that was clear. That felt a little jumbled. We're going to move on to what happens if they give us a picture of a graph, and we want to make the polynomial in the factored form like this. So they sort of give us the zeros. We want to find that polynomial in factored form. So we're going to talk about that right now. So they're going to give you a graph. And then on that graph, it's going to cross the x-axis. So it's going to do something like this, and then like this, and then it might come up, and who knows, maybe it'll come back through. Let's do that. It's good. It might look something like this. What we care about are the zeros, are the x-intercepts. So we're going to care about these points right here where the function touches or crosses the x-axis. Now, especially on a SAT or ACT type problem, or if you're doing a problem in some kind of program, these numbers are going to be, should be, nice numbers. Because they don't want you guessing. If they got a whole bunch of hash marks, they're not going to give you one that's between hash marks and you can't determine exactly what number it is. So this might be like -10, and then this is -6, and this might be at 1, and then this might be at 4. So those x values that we cross the x-axis at are our zeros. So in this case, our zeros are x equals -10, x equals -6, x equals +1, and lastly, +4. Now, just like up here, where we were talking about how the zeros were the opposite of what's inside the polynomial, we're going to use that same theory here, and we're going to move the number to the opposite side to get one side equal to 0. I will show you now. Actually, let's move this way. So we went from our graph, we got our zeros, and we're going to set it up so x is equal to -10, x is equal to -6, x is equal to 1, and 4. So I'm going to do the opposite of that number to make the right side 0. So what's the opposite of -10? +10. So I'm going to add 10 to both sides, and this gives me x plus 10 equals 0. The opposite of -6 is +6. So I'm going to add 6 to both sides, and now this gives me x plus 6 equals 0. What's the opposite of +1? That's -1. So I'm going to subtract 1 from both sides, and that gives me x minus 1 is equal to 0. And then lastly, down on the end, the opposite of +4 is -4. The -4 and +4 cancel, and so I get x minus 4 equals 0. And now each piece of these that's equal to 0 is that factored piece. So our function, our polynomial, is equal to each of those pieces all multiplied together. Now this is a very basic version of how to do this. They might give you some more information. For instance, if they gave you another point not on oh, excuse me. If they give you another point that isn't an x-intercept, they give you another point that's like 3, 4, something like that. What they would want you to do is to plug in 3 into this, find out whatever number you got, and then you'd have to figure out what number to multiply it by to get to 4. I personally am not going to do that today. Most problems won't have you going that far, but if you need to see that, let me know in the comment section, and I can help you with that. So a real quick recap is if they give you the polynomial in factored form, set each factor equal to 0, get x alone, and that tells you your zeros. If the problem starts by giving you a graph, everywhere it touches the x-axis is a 0, and you should make a list like I did. And then from that list, you can do the work of moving the number over to the x side and getting 0 on one of the sides. And once you have 0 on one of the sides of the equations, each of those gives you the piece that goes into your factored polynomial. I hope this makes sense to you all. You'll see me next time. Bye.